In this problem, we're stating that we are 220 feet across from a street from the base of the Empire State Building. We look up at an angle of elevation from the ground of 80 degrees to see the top of the building. I walk 25 feet farther from the base of that building, and I still look up at an angle of elevation of 80 degrees, but this time I can see the top of the tallest broadcast antenna. I want to know how tall this antenna is. To start, I'm going to draw a picture having my Empire State Building with the tallest broadcasting antenna up on top. I know that if I'm 210 feet or 220 feet from the base of that building, I can look up from the ground at an angle of elevation of 80 degrees in order to see the top of that building. I now walk 25 feet farther, or a total of 220 plus 25, or 245 feet from the base of the building. I now look up at the same angle of elevation of 80 degrees, and I can see the top of that antenna. I want to know how tall that antenna is. In order to solve this problem, first I'm going to find the height of the building, which I will call B, and then I'm going to find the height of the building plus the antenna, which I will call H, and then I will subtract the two in order to find just the height of that antenna. I would recognize that in the first right triangle, I'm looking for the opposite side if I know the adjacent. Therefore, I can set up the trigonometric function of tangent, where the tangent of 80 degrees is equal to the opposite over the adjacent, or B, the height of the Empire State Building, is 220 times the tangent of 80. Going to my calculator, I know that the tangent of 80 is approximately 5.67. So now I have the height of my building is 220 times 5.67. That approximates B, which tells me that B, or the height of the building, is 1,247.7, or 1,248 feet. This is pretty accurate since the height of the Empire State Building is 1,250 feet. We are now ready for the second part. If I am a total of 245 feet from the base of the building and look up at 80 degrees, I want to know what that height would be. So again, I have the tangent of 80 degrees is equal to B over, H, the total height, over 245. This tells me that H is equal to 245 times the tangent of 80 degrees. Again, finding the tangent of 80 degrees, multiplying that value by 245 gives me H to be approximately 1,389 feet. Again, with rounding, you might get something slightly different. Therefore, I know the height of the antenna is taking 1,389 minus 1,248. If I do that calculation, I'm going to see that the height of that tallest antenna is approximately 141 feet.